Hello everyone, welcome to the new session on data structures and algorithms. And firstly, welcome to this infinite loop channel. So, as we have seen in our previous session, we have discussed a simple trick to find out the time complexity. Whatever may be the code, the idea is very simple. We need to use that tabulation method in order to find out the time complexity, right? So, in this session, we will try to solve some more examples and we will find out the time complexity. I can guarantee you one thing, with this session, you can get a good hold over the time complexity. Whatever may be the code snippet, you can easily find out the time complexity. Okay, so let's start the session with the first example. So here there is a simple code snippet given for you. You can clearly see there are two for loops, right? First for loop is running till n and the second for loop is running till m. So what could be the time complexity? For this part it is n, and for this part it is m, and we assume this a equal to a plus rand as a constant. Okay, so this is some constant operation. Then what could be the complexity? It can be a combination of n and m. That means the time complexity is big O of n plus m. Okay, you just can't neglect any of these terms because n is different and m is different, right? So that's why I'm writing my complexity as big O of n plus m. Let's solve the next example. In this example, you can see we have declared some variables, and here you can see we have two for loops, right? The first for loop is running from 0 to n, and the second for loop is running from 0 to n. That means this entire two for loops, it takes complexity of n square, and this is a single for loop. You can clearly see it's running from k equal to 0 to n, so it takes n. So generally the time complexity could be n square of n square plus n, but we need to neglect this lower order term, or if we want to neglect, then we can neglect this n, but we can write the time complexity as big O of n square. Okay, so this is the idea of this question. Talking about the next, we can see till now we haven't used the tabulation method because the for loops are clearly visible to find out the time complexity. We are just doing a manual method to find out the time complexity. Okay, so from this question we will try to use this tabulation method because for some questions definitely you need to take your pen and paper to find out the time complexity. Okay, so talking about this question, you can clearly see the first for loop is running from 0 to n, and the second for loop is running from n and it is something greater than I and it's getting decremented. So basically whenever you are given with these kind of code snippets, the first thing is you need to write down the variables present in the for loop. Firstly, I have I variable and I have j, and the next one will be the total iterations, right? How many iterations it's taking. So I need to separate them like this. Okay, so in our previous session we only had I, right? But here we also had one extra thing, that is, I mean, internal for loop, that is j. So that's why I kept here j as well. So what we can write here, tell me, I is starting from where? I is starting from 0, and j, you can see here, you just directly can't write j as n here because you can see j is starting from n, and you can see j is greater than I. That means j is greater than 0, right? J is greater than I. This expression simply means that j is greater than 0. That means your j will definitely lie between what? N to 0. It's as simple as that. But here there is an important thing that you need to keep in your mind. J is equal to n. That means j is starting from n, but j is greater than I. That means j is greater than 0. It is not equal to 0. It is just greater than 0. So that's why I'm writing a closed bracket here, right? You can clearly know this difference, right? The square bracket is indicating this and greater than this values, and this parenthesis will represent values greater than this thing. It does not include this thing. So this is the idea of writing I and j, right? Similarly, for I equal to 1, what can you write? You can write n, because you can clearly see for every time j starts from n only, and j will be greater than I. That means j will be greater than 1. So that's why I'm writing here 1. Similarly for 2, you can write the same thing, n greater than 2. So it goes on like this, right? Now the biggest question you will be getting, how to find out the total number of iterations. Do you simply say here there is a constant operation, you simply write here 1? Of course not. It is not 1, because you can clearly see that it is not only one for loop, you have one more for loop inside it. So the total number of iterations will be these many iterations from n to 0. That means the total number of iterations will be n. Okay, the total number of iterations will be n. I'll tell you why I'm writing it as n. Remember, you know this simple mathematics, right? If I take some a and b, two variables, okay, if I take these two variables and if I do something like closed brackets a and closed bracket b, right? And you can have something like this as well, and you can have something like, open a and closed b, right? And you can have something like both of them parentheses, right? So these are the four possibilities that you can have, right? Generally I'm talking about like how we can find out the iterations. If both of them are included, that means a is included, b is included, and that means the values will lie between both of them, then the formula will be b minus a plus 1. Okay, it is a simple mathematics, right? You know it, why I'm writing here plus 1. And if it is equal to a, but it should not be equal to b, but it should be less than b, then what is the formula? Simple, b minus a. Here also the same thing, b minus a. Why? A is not included, but the values are between a and b is also included. For this thing, I mean both of them are closed brackets, right? So for this thing the formula will be b minus a minus 1. So these are very important, guys. You just don't try to remember them, but it's very easy, right? You know why I'm writing it like that, because this square bracket represents including that value and this parenthesis represent does not include that value, right? So that's why I'm writing it something like this. So here you can see, here you have one square bracket and one open parenthesis. So I need to use the formula as b minus a. That means you can simply subtract both of them, right? So that's why I've written here n. Okay, and similarly for this thing it will be n minus 1. For this thing it will be n minus 2. So something like this it will go on, right? Let me try to move this to some side part. Else let me move it downwards. Yeah, you can see here. So here we have seen the total number of iterations, right? From n and n minus 1, here it will become n minus 2, something like this. So you can see here it will run till, I will run till n, that means less than n, that means I will run till n minus 1, and j is as simple as that, include n because j is starting from n, and j is greater than I, that means j is greater than n minus 1. So you can write n minus 1, you can close the bracket, and here the expression will be what? N minus 1 minus n, that means 1. Hope you got it, how I got 1, because simply we are subtracting each of them, right, every time. So here also I'm doing n minus of minus 1, that means it becomes plus 1. N and n will both get cancelled, right? So this is the idea of this tabulation, right? Now the only thing that is left is finding the summation of these iterations. So you just add all these things. You can clearly see this part, this total iterations, it is something like this: 1 plus 2 plus 3 so on plus n. Hope you got it right. 1 plus 2 plus, I think before this you might be getting 2, and before this you might be getting 3, and you can clearly see last value is n, that means it's starting from 1 and it is going to end at n, right? So that's why I have written it something like this. So this is a simple sum of n natural numbers, which comes out to be n into n plus 1 divided by 2. So we can write it something like n square by 2 plus n by 2. So if we try to neglect this n by 2, that means which is a basic lower order term, then what would be our answer? Our answer would be this n square divided by 2. That means Our answer is what? Big O of n square. So for this code snippet, the answer is big O of n square, right? Hope you got it how we came across this thing, right? So you also try to remember this thing as well. This has been a crucial one, right? So for solving the problem, I'm just putting it over here. Okay, so that is the idea of this problem, guys. Talking about the next code snippet, in this code snippet you can clearly see I have written a simple while loop, right? So it's not a typical for loop, but here you have a while loop and only you have I, right? So I'm going to write I and I'm going to write the total number of iterations. Again the same tabulation method. So I is starting from n, right? So I'm writing here n because you can clearly see I is declared as n. And after writing n, can you tell me how many times it's running? You can clearly see while I greater than 0 we are checking some condition and you can see some constant operations, right? Addition and division, something like this. So here hardly it takes one iteration. And what happens to I value? You can clearly see I is divided by equal to 2. That means I will become n by 2 because I was initially n and in the next iteration it will become n by 2. Again it runs for one time. Again what will happen? This n by 2 will become n by 2 divided by 2. That means n by 4. So again for one iteration and again n by 8 again for one iteration. So it goes on like this, right? So you can clearly see by this time it has completed one iteration. By this time it has completed two iterations. By this time it has completed three iterations. By this time it has completed four iterations. I'm just writing a summation of this, right? Like 1 plus 1 it's 2, 1 plus 1 plus 1 it's 3, and 1 plus 1 plus 1 plus 1 it's 4. So what happens to this I value? You can clearly see I is greater than 0, right? So I can be somewhere something like n by 2 power k. I can write, if I assume this k to be some random value, then it will become what? N by 2 power k. So what will be your total number of iterations now? Total number of iterations will be, you can clearly see here, this is n by 2 power 0. Wait, let me write it here so that it becomes easy for you. So this is something like n by 2 power 0. This is something like n by 2 power 1. This is something like n by 2 power 2, and this is something like n by 2 power 3. So for n by let me change the color, guys. You can clearly see here for n by 2 power 0, for n by 2 power 0, this part it is running one iteration, and for n by 2 power 1, you can clearly see by the time it has completed two iterations, and for n by 2 power 2 it has completed three iterations. So for n by 2 power k, then how much it could have completed? It's as simple as that, k plus 1. Hope you got it why I have written plus 1. You can clearly see 2 power 0 it's 1. So for 2 power k it will be k plus 1. For 2 power 1 it is 2. That means if I assume this power to be k, then the iterations is something like k plus 1. So that's why I've written here k plus 1. So this k plus 1 is your actual answer. But you need to represent the time complexity in terms of n. So how I can write it? Okay, you can clearly see I is greater than 0, right? While I is greater than 0, you are performing these operations, right? So there might be a point that I will definitely become equal to 1. Will you agree with this point? I is greater than 0, right? So there is a situation that I becomes 1. Okay, so if I becomes 1, then simply you can write n by 2 power k equal to 1, because I is nothing but n divided by 2 power k, right? I is nothing but n divided by 2 power k. So from this what I can write? Let me draw here. So from this I can write n is equal to 2 power k, and your k will become what? Log n base 2. We have seen in our previous video, right? Same kind of complexity, right? So you got the k value, so your complexity will be, I mean, your the iterations will be log n base 2 plus 1. But if we need to neglect this one, so your answer will be big O of log n base 2. So this is your answer. Hope you got it why I have told here I equal to 1, because I is greater than 0, which means there is a possibility that I can hold value of 1. So that's why I've written I equal to 1 and I'm trying to get the k value from it. Okay, so that is the idea of this question, guys. So this was about this video. In the next video we will also discuss some more interesting problems, right? Thank you for watching. Please have a like and try to share with your friends, and definitely don't forget to subscribe to my channel. Thank you.